Okay, so turn it on. And you can see that it's going to go over there towards the wall. And you can see that both of the sensors actually work pretty well. Right? If I go like this, or I can just put my head in front of it. Hey everyone, we are ready for experiment number 2 and hope you had a lot of fun with experiment number 1. In this one, we're actually going to make the robot be a little smarter. So we're going to make the robot navigate autonomously. So this robot with sensors will run around on its own without, well, as it bumps into things, it can back away and turn to another direction. Or it'll have two sets of sensors. It'll have some switches in the front, those are called feelers, and it'll have also infrared sensors. So with those, it'll be able to detect things and back away from different things. So let me show you what we need to do first. So first, we need to install the little switches, which are called the feelers. When this detects something, it presses the switch, right? And then it sends a signal to the Arduino saying, hey, I hit something on this corner or this corner. And so we're going to wire them up like this. Well, this is how they're installed on the actual board. You can kind of see it on the robot itself, right? They're just installed here on the first layer, and that's how they are. Right, so when they hit something, either the left or the right hand side, it'll know and it'll back away. There's also infrared sensors that can detect things. So you got primary sensors and you got secondary sensors as well. So let's see what we need to do first of all. Okay, this is what it looks like on the other side. So these are just basically digital input sensors, right? They're just on and off switches. It tells us whether something has been hit, which is high or low, and this is how it is. A simple circuit like this can actually imitate that same setup, right? It's just a switch. You got a couple of resistors, and then when you press it, you're sending the signal out to one of the pins, like pin number 7, and you're closing it. So in this case, for example, you see this is connected to the 5 volts here. Okay, so right now this is connected to the 5 volts on data port 7. So that means that right now the signal is high, or it's got a 1. The moment I press the switch, it'll sync it. It'll sync it over here to ground, and now the value is going to be 0 or ground, basically 0 or nothing, right? No voltage. So that's what this is doing right here. It's looking for the button, and based on the button, it will send out a signal. In this case, you can turn an LED on and off if you want to. There's a built-in LED on the board, and by pressing it here, you're turning that LED on and off. Okay, so you can go ahead and try that particular example. Here's another example of when the feeler is pressed or not pressed. So right here you got 5 volts connected to this pin number 7, so it returns a 1. The moment that I press the switch, I'm going to sync the voltage to ground, and the value is going to be a 0. Okay, and we have a couple of resistors here to protect the amount of current that goes into the port. Okay, that way we have the 10K resistor and the 220 ohm resistor. Make sure that you're using the correct size resistors over here, especially the 10K resistor, which is I believe is brown, black, and orange. Okay, you got the brown, black, and orange here. So see, this is how we're going to wire our sensors. You have the wires that come out of the sensors are 3 wires. You have this wire for that switch, that wire for that switch, and you have a ground common wire. So I basically just looked at this graphic here, and then I wire wire my sensors the same way. I got a couple of resistors, the 220 ohm, and I got the 10Ks. And basically, I just use some extra wires to connect it. Right, so you have your kit comes with a lot of wires, and so you can just use them. These are called DuPont wires, and you can just plug it in there. Okay, so be careful of what you connect. Right, you have, remember, your little shield here has all the ground. Let's see if we can focus, make it focus here. Right, you have ground, voltage, and signal all across these pins here. Also remember that row of pins does not turn on until you turn flip the switch over here. Okay. So I did that. I wired up just like you see it over here. Keep in mind this is the breadboard, right? And on the breadboard you have some connectors that are already connected underneath the board. There's a little metal plate down there. Okay, so make sure that you look at that very carefully. Okay. See if I can make it closer here. There you go. Loses it's got this autofocus, but then it loses the focus. There you go. Okay, so yeah, some of these webcams can't do too much of a focus, but you get the idea. Everything gets wired up temporarily. Again, I have my robot sitting on a little box, right, so that the tires can spin freely. And let's see what else we need to do. Once we wire this up, you know, what I did was I started off with the middle wire, which is my ground, and I plugged it right into the ground. Okay. Then what I did was I grabbed a couple of 220 resistors and I plugged them into the right pins, which is pin 5 and 7. And then I plugged in the other two, the 10K resistors. Okay, and then I plug in the 2 wires from the switches right into the middle of that connection, and the remaining 2 basically went to voltage. They go to the 5 volts. Alright, and here's a schematic. If you prefer to read a schematic, this is what it looks like. Okay. And this is just representing of what happens when you hit the switch. So right now it's 5 volts in the meter. The moment you hit the switch, it goes to ground, right? So it becomes, let's see, so right now it's 5 volts. When you hit the switch, it goes to 0. Actually, in this case, it is connecting to the meter. Okay, so this is just representing the meter. The meter right now is ground, but the moment you press the button, it goes to 5 volts, okay? So it's a pull down or a pull up resistor. And you're going to see that, the pull up and pull down resistor, later on. These are some industrial sensors that are out there. And they're based on basically transistor logic, but it's the exact same thing as having a switch, right? So it's connected the same way, where you can sync and source the values. These are the sensors that are used in industrial robots. So it's the same thing. You get an output of a 0 or you get an output of a 1, depending on what the sensor is looking at. Okay, here's that same thing again. So the standard that I've seen everywhere is that if you are not touching anything, you get a 1. Right, no feeler contact. This is how it's wired. This is how they do it in a lot of the industries. So no contact gives you a 1. The moment that you hit something, you get a value of a 0. So we're gonna write a little program right now that will let us test the sensors to see if like the 1 and the 1, this is the left and the right sensor. We're going to write a program that tells us whether or not the sensor on the left or the right is being pressed, right? Whether or not this guy or this guy is being pressed. Okay, so let's do that right now. You continue going down here. So this is called active low output. Okay, they're wired for active low output, which means that each send a low signal when they're pressed and a high when they're not pressed. Okay, so a lot of circuits in industry are wired active low output. All right, so let's do a test. Let's copy this program. Okay, paste it into the Arduino IDE. Go ahead and run it. Don't save it if you don't have to. So for this one, okay, so I have it doing a little beeping sound to begin with to make sure that it tells me that it finished. So right now, if I hit this, you're gonna see that nothing happens, right? Let's see if you remember why when I hit this, nothing happens. Let's go over here. Okay, so nothing happens. Why is that? Remember, we're connected to this row, and that row gets activated only when we turn the robot on. So turn the switch on. Got that purple LED right here on. So now we see a 1 over here. Remember, this is active low. So if I was to hit the switch here, right, on the left, it turns the 0. If I do the 1 on the right, it turns that. Okay, so this is my left, and this is my right. Okay, if for some reason you connected it to the wrong place, so like for example, this is input number 5, and I noticed that input number 5 is the right according to this. So let me see where input number 5, so this is my left feeler. Let me see where input number 5 is here. Input number 5 looks like I have a purple connector. So let's see. Input number 5 is yeah, the purple connector, which is this yellow one, which is my left one. Okay, so number 5 is left, so it looks like I have it connected to the right place. Okay, so you just have to look at the wiring to make sure that you plugged it into the right pin number. Okay, and again, we can I can turn on the serial monitor, and I can double check that each one is properly activating. All right, so we know our sensors are working. So now, what else do we need to do? Let's see. This just explains a little bit. This is an optional program. This one will basically turn an LED on when you press the feeler. It's up to you. It kind of will help you to understand of logic and how to it'll help you to how to have multiple things inside the same program, not just to test the switch, but also to write something when a switch gets pressed. So it's put here on purpose. It's kind of optional, but if you understand how this works, you can skip it. But if you want to know how to activate something when the switch gets pressed, please go ahead and do this particular exercise. So navigating with some feelers. Okay, so we're basically going to write a program that it goes forward, and when it hits something, it tries to avoid it. Okay, don't forget we did that servo lab in the beginning. That is going to help you quite a bit. Okay, so what we're going to do here is we're going to attach this program. Start over here. Let's download that program. And I'm liking the putting in the tone, so that tells me a little bit that the program has been run successfully. Kind of like an indicator for me, but I'll put it in there. It's uploading. It's done uploading. And so what this is doing is it's making the robot, well, the robot is going backwards right now. But if I press a switch, it'll try to avoid it and it'll turn in another direction. If I press the other switch, it does the opposite. Now the wheels are going backwards, so what I'm going to have to do is I'm going to have to make a swap over here. What that tells me is that I have my left and right servo attached opposite of each other. So I want to make this one servo 10 and this one 11. So by swapping it, the wheels are going to go in the opposite direction. So let's try that and see what happens. So now it's going forward, right? This is the front of the robot. So now if I press this switch, which is the left one, it should go back, right? And then it should try to go in the opposite direction. Same thing if I press this one here. It goes back. See, it goes back. And then it tries to go forward again. So it goes back. It tries to do a little turn and then it goes forward. So let me see if I can let it loose for a second here. So you can see it. The moment that it presses something, it tries to avoid it. Okay. So that tells you that the robot is working. Now you can make the program or the robot go a little bit further, because right now it goes pretty fast. It tries to make a quick turn and it goes pretty fast. But we can make that go a little bit further by applying by changing the forward or the backward time. Okay, so we can change the time variable as well. So let me see. So we have our servos connected. We have our switches connected. We have our tone. We have a left and a right variable where we're storing values. That way we can read the values. So we store values into variables so that we can read them, right? This using the digital read function. And we're just saying right now that if both our pillars are pressed, then go backwards and turn left. You can change this number, and that will change how many degrees this will turn. Okay. And then else, if only one filler is contact, then do backwards the other direction. And what this number will do, this will also change the amount of time that it's been that is going to turn for. Okay, and you also have, let's see. Okay, you also have this forward function here that you can specify the amount of time that you want into, and you can go forward. So really you can create functions and assign it your own amount of time that you would like it to turn for. Okay, so we got all these functions here, and we are making the robot go left, right, forward, and back. And so that's how you do that particular one. Okay, this one will go back for just 1 second. this one will turn left about 120 degrees, but really is based on the amount of time. These are milliseconds. Okay. All right, so you at least got it maneuvering now. Now your second part of this particular lab is now going to be assigning the primary sensors, which are these infrared sensors. So these sensors are really exciting. They have this variable resistor here, right on the top here, and you can adjust that with the screwdriver to see the distance of how far do you want it to detect. How far out do you want these sensors to detect? This sends out a signal, sends out a little light, infrared light, that you can't see it with the human eye. And then the other guy receives the light. So this one sends it, the clear one sends it, the dark one here receives it, and it bounces off an object. Depending on the distance that has been assigned, that's how far that signal is going to go and come back. And it's going to tell this chip to translate that signal into a 1 or a 0. And then you send that signal via the signal connector here right to the computer. And that's how you tell the computer that the sensor has detected something. All right, so let's see what it's going to have us do next. Okay, so this explains to you how the whole navigation part works with the one particular sensor. Okay, so it tells you a little bit more here, a little bit more. Okay, this is a little bit of an artificial intelligence added here for escaping a corner. So let's say that the robot is stuck in a corner, okay, and the robot is going into a corner and it's going to hit the corner, and it tries to go away, and it goes to the other side of the corner, and then it hits the other side, then it backs away, then it goes in, and it keeps doing this, and it gets stuck in a corner. Okay, so basically it gets stuck in the same corner. So we got to figure out a way to tell the robot, hey, you've done that too many times. Go back far away, make a turn, and get out of there. So how do we do that? We assign a little bit of AI here, and what we're going to do is we're going to do some nested if statements. Okay, and what you do is you will have a counter, and we're going to say that if the counter reaches that 4 times of doing the same thing, then hey, you're stuck in a corner. Go ahead and do a U-turn and get out of there, and then clear the values of that counter so that we can know if we're stuck again in a corner. Okay, so this is really neat. We got the same forward backwards functions, and so let's look a little bit about this. So we have let's see if we can find the there we go. So let's look at the sketch. So we have these variables, right? The left and the right variables. We have the counter, and we have for the old values. So it's storing values in these variables. Okay. It also, let's see, initializes the feelers, right? So that it does have different values in there. Okay, we're using the not operation, right? This is the not equal to. Okay, so if the left and the right are not equal to each other, then that means that one feeler got pressed. Okay, so that's going to start the counter, and it increases it by 1. This is the counter plus plus. Okay. So then it goes and keeps recording. So every time you hit it, it keeps recording it and recording it. Okay, so then it says if the counter has reached 4 times, okay, then go ahead and reset everything, but make the robot make a U-turn, and go the other way. Okay, so it makes basically a U-turn and goes the other way. That way it leaves it. Okay. So that's the whole idea behind it. It's basically storing it. Okay. So here's the Cornerscape algorithm. You have the two, the left and the right switches, right? So if the left is not equal to the right, then boom, you have hit it one time. So if the left is not equal to the left old value, and the right is not equal to the right old value, then that means you hit it again. So go ahead and add it again. Okay, add another one. Okay, so it does that several times until it knows that, it goes through the whole thing until it knows that when the counter hits 4, that it resets everything, and then it goes back to make a U-turn, and then it gets out of there. Okay, so it's a really neat example of nested if statements in there, and it works really well. There's other ways to do it. There's another way to do that, and I'm going to go to the end to show you that. Okay, so it's called the modulo operator. And so what you do is you take the remainder of a division, and when the remainder is equal to a set amount of times that you give it, like 4 times, then at that point it goes to a function. But we're going to study modulo operator in detail in the lecture, because I have to give you several examples with that. But check this out. State change detection, edge detection. Often you don't need to know the state of a digital input all the time, but you need to know when the input changes from one state to another. For example, you want to know when a button goes from off to on. This is called a state change detection or edge detection. This example is going to show you how to detect a button when a button changes from off to on and on to off. So let's copy this real quick, and let's run this example. And this one is using the modulo operator, by the way. That %4 means that when something has been divided and it gives you a remainder of 4, then at that point it knows that that something has been hit 4 times. So let's quickly paste that sample in there. I'm not going to save it. Okay, I probably didn't copy something correctly. Let's see. Go back to the document. Probably missing 1 or 2 things. I'm going to do it from here. Oh, okay. Sorry, I forgot that I unplugged the robot when I was doing the demo. So, remember that the Arduino needs to interpret the code that is compiled, so code won't run until you have it plugged in there. Okay, so let's try it again. And it says done uploading. Let's open our serial monitor, and let's open our camera here so we can see what's going on. Where's my serial monitor? There we go. Okay, so basically if I press the right switch, and remember that doesn't work because we need to turn on our robot. Okay, I want to make sure that you're all aware of that. Alright, so that's the wrong switch. The code says that the switch is connected to switch 7, so it will be the other switch on this side. Okay, so I'm going to press that switch. Okay, so it shows you exactly when it goes from the off position to the on position right away. Sometimes you want to know that very specific time when that happens. And see how it's accumulating over here? Okay, so this little program can help you get very accurate number of state changes of a button. Okay, so the number of pushes and things like that. This could help you as well to solve that problem of escaping the corner. All right, so the next thing is, and this was the main thing that you're required to do for the lab, is to actually connect. To do autonomous navigation, you're going to have to add extra sensors. So you're going to leave what you have there, but you're going to add and connect these two sensors that you see here. These are infrared sensors. The little potentiometer on top here, you can adjust the distance that this is looking at. And all they do is they have a ground, they have a signal, and they have a voltage. So they have 5 volts, they have a signal, and they have ground. For this one, let's use this particular power grid over here. This is 5 volts to add into to this particular sensors. Because over here the voltage runs a little bit higher, so you want to use the voltage from here, but you want to use the signals over here. Okay. And those sensors on the robot are just right here on top. All right, so your job is to, here's some of the specs for those sensors. All right, the distances from 2 to 30 centimeter. Distance. A little bit about infrared lights. Again, infrared lights are basically sends out a wave, and when it detects something in the front, it bounces back to the receiver. Okay, so the following code can test the IR sensors. So I'm going to connect them, and then we're going to test this particular code. All right, so I've connected the sensors, the IR sensors over here. You can let's see if this autofocuses. There you go. So you got the sensor over here, and you can see there's a little light here that turns on the moment that I get close to it. You can see the little light here turning on. Now on this one, I noticed that I have to be really close. See, this one turns on when I'm about this distance, which is perfect. But this one, I have to get really close. So what I'm going to do is I'm going to adjust it over here so that, let's see, I want to turn it so that it actually is more sensitive the further out I am. Perfect. Okay. So now I don't have to be super close to it. It'll be triggered. So one slight movement here allowed me to fix that. All right. So let me see if I can, there's a way to put the robot further up, so that you can see it better with the camera. That still doesn't autofocus, unfortunately. I gotta get some better camera here. Okay, well, that'll give you a much better idea of how this is to be wired. Seems that it's clear if it's further out. That's fine. All right, so I put in the power, and then remember the power, I put it up on this bank of power. Right, it's just safer. I mean, it'll work if you put it on this other bank of power, but it's much better here. Okay, so if you recall, there was a code here that will allow us to test those sensors. Okay, and it's this one right here, the IR obstacle collision, and one of the sensors is on pin number 3, and we're going to read the values of it by doing a digital read, right? And if the value is low, then there's going to be an obstacle in there. Okay, and it'll turn on an LED. So let's see what happens. Okay, again, the sensor has voltage, ground, and output, and a nice distance adjuster. So I got the code over here. I'm going to upload it. Okay, it's done uploading. I'm going to turn on my serial monitor. All right, and this is the sensor that is attached to. So if I put my hand near it, you can see that it tells me that it's been pressed again and again and again, right? So we know that it is working. We know that particular sensor is putting an output. This is similar to the switch. Okay, very, very similar to the switch. It's a digital sensor. So the sensor itself has a chip in here that does the conversion from analog to a digital output, which is very convenient. Now you might recall there was another piece of code that we tested before, and that was our original tester where we were reading the switches. So remember, for this particular program, we're putting these sensors on pins number 3 and 8. 3 and 8. So if we look at that first sample code, you got to make sure that you change that to those pin numbers. Okay, and 3 and 8. And that should do it. So let's run this program. Okay, it tells me it's ready. Let's see, as you recall, this particular program over here, left and right should be 0 the moment that it detects something. So there's that, and there's that, right? And if I do both of them at the same time, right? So we know that our sensors are working really well. Okay, so again, this program was previously from our, the beginning of the manual on how to look for it. All right, so the next thing is we can continue figuring out what else we need to do. So we need to figure out how to add our IR sensors and our feelers to the code. Okay, and that's going to be part of your experiment. And unfortunately, I don't give you the final solution, so that it's up to you to figure it out. But there's a way for you to declare all the variables and put it all together, and then have it working. So let me see if I can upload this. Okay, so we're copying this example here, the final solution, and we're going to basically paste it in here. I got a solution here to have both sensors, so I'm going to upload it, and let's see what our little robot does. Okay, so I want to turn it on, turn the switch on, so you can see that the robot is turning. If I go to the top, it goes to go back. Right? If I come here just to the switches, it also knows to go back. Right? Right, so I'm going to put it on the floor and see how that goes. Okay, so turn it on. You can see that gonna go over there towards the wall. And you can see that both of the sensors actually work pretty well. Right? If I go like this, or I can just put my hand in front of it. And you can see that the secondary sensor works pretty good too.